So, do you know when your deadline is for your makeup work? Which is what? Friday. It is on Friday. And so, we are working toward solving logarithm equations. Before we can solve logarithmic equations, we have to know what they are. So, how do you get a logarithm equation? For example, how do you turn this exponential equation into a log equation? Would you please write this on the left-hand side of your notes here? Do we remember from Friday how to make this into a log equation? Base what? 6. This is the base on the exponent. It's the base on the log. And then these two switch places. And so that is how you write the same equation in log form. A log is a inverse of an exponential. On your paper, on the left-hand side of your notes, please write this in a log form. Did you write it correctly in log form? Now, what we're going to be doing in just a few days is solving for that x. Does anybody happen to know what that x would have to be? 5 raised to what power would be equal to 125? I see the correct answer in the back there. It is 3. X would be equal to 3. Can you write this log equation in exponential form, please? How'd you do? Those are the kind of problems that we were doing on Friday. If you were here on Friday, I do not need you to turn in worksheet 10-1. But if you were absent on Friday and had to do this paper as makeup paper, I do need to see the makeup papers only. And so then, today we are going to use the properties of logarithms to expand logs. The reason we do this is because when we solve, sometimes we need to expand our logs to separate the variable so we can isolate the variable and solve the variable. So we have 3 rules: the product rule, the quotient rule, and the power property. And I will show you how to use these properties. So right here, these numbers right here, are they added, subtracted, multiplied, or divided together? They're multiplied together, and another name for multiplication is product, so we are going to use the product rule. The product rule says multiplication changes to addition. The base does not change. This is log base b, and this is log base b. So, to expand this, log base 7 of 5 plus log base 7 of x plus log base 7 of y. The multiplication changes to addition. That is how you use the product rule. Where does the product rule come from? I will let you think about the answer to that question When you are thinking about the answer to that question, think about the exponent rules. Right here, these numbers are divided. Another name for division is quotient. So I will use the quotient property. For the quotient property, division changes to subtraction. Now it is expanded. All I'm doing is applying the rule. Why would I want to do this? Well, this is going to be one part of solving for an equation. So, do you see that x is raised to the third power? So I will use the power property, and on the power property, the power comes from over here out in front. This is going to be one of the most useful properties when I am solving equations. So this power is going to come out in front of the log base 2 of x. And that's going to help me solve for x when I have some equations that I'm going to be solving. Problem number 4 has two things going on. It has some multiplication and it has some exponents. So I'm going to use the power property, the product property first and the power property second. This becomes log base 3 of 4 plus log base 3 of x squared plus log base 3 of x to the 5th power. That is the product property. Then this power is going to come out in front of this log, and this power is going to come out in front of that log. Thank you. Double checking there it is. There is two rules, the product rule and the power property. Now, before we go on to this one that is a little bit more difficult on your homework paper, I want you to complete problems 4 and 5. Problems 4, 5, and 8 from your homework are fairly simple problems. Please go back to your notes because the next problem coming up in your notes is not so simple. It's going to have all three properties in one problem. We are going to start with division. Division changes to subtraction. Log base 7, 2x to the 3rd power y 8, subtract log base 7, 3z to the 4th. So, the division changes to subtraction. And then we need to use the product property next. Of x to the 3rd plus log base 7 of y to the 8 minus What? It is a long problem because there are a lot of terms here. This term right here, this first part is log base 7 of 2 and x to the third power and y to the 8th. And then these two are subtracted. This is the denominator, and we're not done because now we have some powers. This power needs to come out in front of this log. The 8 needs to move out in front of that log, and this one needs to move out in front of that log. So what do we have now? Log base 7 of 2. The 3 comes out in log base 7 of x. The 8 comes out in front of that log. Minus, this is so long I can't fit it on one line, log base 7 of 3. This 4 comes out in front of log base 7 of z. No. Once you get used to doing these, you can probably combine some of these steps and not have to do everything out in a separate step, but there is no shortcut. There is, however, one other additional way you could write the answer. All of this is subtracted right here because all of that was in the denominator. And so we can also distribute that negative, and this would also be a correct answer. You can write it with the parentheses around this term and this term positive, or you can distribute the negative, but so there's more than one way to write the correct answer on this particular problem. Once again, when you have a kind of complicated problem to start with, it's going to be kind of a long answer when you're done. This has division, so we're going to start with log 3 x squared minus log base 3 and then probably the next thing would be to use the product rule on this part right here, log base 3 of y plus log base 3 of z to the 4th power. This part right here expands to this part with the parentheses. Then we have the power rule. This power goes in front of that log, and this power goes in front of that log. 2 log 3 of x minus parentheses log 3 of 4 plus log 3 of y plus 4 log 3 of z. You can write the answer like that, or you can distribute the negative. Oops. So you can write the answer like this or like that. Both of those would be considered correct answers. What? Not yet. Question? Did someone have a question on that? So, what are you going to do about this next problem that has a square root in it? Do you remember another way to write a square root? Do you remember that a square root can be x to the 1/2 power? A 1/2 power is the same thing as a square root. Then you can use the quotient rule. Division changes to subtraction. Then you can use your power rule. That one's not quite as complicated. That is your final answer. This is called the expanded answer. And once again, the reason we're expanding is so that we can solve problems 2 days from now. Once again, you are not going to leave a radical sign in your problem. Do you remember how to change a radical sign to a fraction? The index of 3 becomes your denominator. Now, do you notice this one does not have a base? Did you notice that? Because if the base is not written, the base is 10. If the base is not written on the problem, the base is 10. Base 10 is your most commonly used base in science. It's called the common logarithm because it's the most commonly used. And if the base is not written, the base is 10. Division changes to subtraction. The power rule says the powers, the exponents, come out in front. That is the correct answer. But just like in the beginning of the problem, if the base is 10, you do not have to write the base. You can write it with the base 10, or you can leave the base 10 out. And I believe that is all of your problems. The first thing all of your examples. The first thing on your homework paper is to copy your properties